Hello everybody, I am Piyu. Today I will be showcasing my project that I have done during my internship at Ivy Professional School. My project is on employee promotion prediction using predictive analytics. What is employee promotion? The ascension of an employee to higher ranks. Some of the advantages include increase in salary, rank, responsibilities. It also aids in employee satisfaction, employee engagement. But the most important thing is it reduces attrition. Our objective is to predict whether an employee of an organization will be promoted or not. We have built a classification model with the dependent variable y and the significant columns as independent variables or predictors. The tool used for this analysis is Python. Next, we come to the data processing part. The given dataset is a sample dataset of an organization employee details consisting of more than 50,000 data points and 14 different attributes. Is promoted is our dependent or target variable. 1 is when promoted and 0 is not promoted. And rest of the attributes are our independent variables. Next, we come to the data pre-processing part. We have followed our standard process like checking for duplicate rows, checking for missing values, feature engineering, outlier removal, conversion of categorical data to numeric, and data scaling. I want to highlight two important points: feature engineering and outlier removal. We have created two new columns like performance and total score by feature engineering. The KPIs met and awards won columns are inconclusive individually in the count plots. So, for the ease of analysis, the two columns are combined into a single column called performance using the any function. Basically, any employee who has either won an award or has met the KPIs has shown good performance. Similarly, the columns number of trainings and average training score specify the number of company organized workshops and the training the employee has attended and the average training score the employee has received for the said trainings. The two columns individually do not present a good assessment since they cannot be compared between two employees. So we have created a third column called total score, which gives an estimate of the total score received by an employee. The column is a good factor to compare and differentiate between employees who have shown improvisation and those who have not. Next, we come to the outlier part, checking and removing them. So we have performed extensive exploratory data analysis on each and every column. The dataset has huge imbalance in the target classes. Now, training a classifier on imbalanced classes can prove problems in precision recall of the model. For this, oversampling is done and the class with lesser representatives is increased. The function random oversampler from implearn over dot oversampling module is used. Undersampling would have caused a lot of data loss. Length of service and total score column have outliers too, and they are treated with the most logical values. Next, we come to the analytics part. We have performed ANOVA test or analysis of variance test and chi-square test. ANOVA test is performed on categorical versus continuous columns, and chi-square test is performed between two categorical columns. To further dig down, we have also performed visual exploration of relationship with box plot and grouped bar chart. P-value of below columns like average training score, length of service, total score, performance, previous year rating, and number of trainings are coming less than 0.05, and these columns shows a good correlation values. So next we come to the model building part. At first, we have done a trend test split on our data. We don't use the full data for creating the model. Some data is randomly selected and kept aside for checking how good the model is. This is called testing data, and the remaining data is called the training data on which the model is built. Typically, 70% of data is used as training data and rest 30% used as test data. Using sklearn model selection cross-validate function, the entire dataset is cross-validated on the entire dataset to see how the model performs on this dataset. The cross-validation gives a good method for model selection. The model which performs good on cross-validation is then chosen for further analysis, for further training, testing, and hyperparameter tuning. The machine learning model chosen here is gradient boosting classifier. The model is a good classification model and removes any bias in the data. It is robust to overfitting. Since it uses ensemble technique, various trees are used as predictors. One tree can develop bias, but the combination of outputs of many trees gives a stable result. Thus, it can be concluded that gradient boosting classifier is a good predictor for this data set. The next step is hyperparameter tuning. This tuning this tunes the parameters of the model to the best set that can maximize the accuracy of the model. Keeping the learning rate at zero point 0.1, the max state of the trees is varied between 10 and 25 to get optimized value. We have also done a validation curve of the train and test accuracies versus a parameter under optimization. Validation curve for the test accuracy identifies the optimal value of max depth for classifier. In this case, the max depth value of 20 yields a average test accuracy of 94.94%, which shows the model has learned the classes very well and is highly trustable in prediction. We have done a final model bidding with gradient boosting classifier. The model achieves 100% precision and 92% recall on the test set. The model is now ready to predict which employees get promoted and which do not based on above good variables. Finally, the inferences drawn from this analysis are as follows. The performance column, which is an amalgamation of KPIs met and awards won, is a good factor to predict which employees get promoted. The average training score and the number of trainings attended combine to give the total training score. Employees with mediocre or high score are likely to be promoted. Gender as a factor has no impact on the promotions of the employee. Both the genders had about equal percentages of representatives from the two sets. The age and service categories give a temporal factor for the employees. Employees who are middle aged and established or experienced have high chances of being promoted. The most important factor amongst all is the previous year rating the employees have received. The chances of promotions increases as the rating increases for an employee, which proves a consistent performer. Department and education of an employee hardly gives much insight into which employee is likely to be promoted. So finally, we come to a conclusion. A recommendation of this analysis would be promotion prioritization as below chronology. Priority 1, employees with consistent high performance rating and high or mediocre training score. Priority 2, employees with longer experience should be considered next. Department or gender should not be a significant factor for selecting employee promotion. A final word. This is a famous quote by a famous HR personnel, Leslie Joyce. The linchpin for organizational effectiveness is having the right talent in the right place at the right time. That's all. Thank you.